Properties of conditional probability. In this module, you will learn about the properties of conditional probability. Before beginning our study of properties, let us understand the definition of conditional probability. Look at the pizza. It is divided into 8 pieces. The total number of slices of the pizza is 8. This implies that n of s is 8. Look at the toppings. We have green capsicum, mushrooms, olives and corns as toppings. You have pulled out a slice of pizza that contains green capsicum. How many slices have green capsicum? The probability that the slice contains green capsicum is given by 5 by 8. Out of the slices with green capsicum, how many have mushrooms? The number of slices which have mushroom and green capsicum is 3. The probability that a slice contains mushrooms, provided it contains green capsicum, is 3 by 5. Let us now recall the definition of conditional probability. Let E and F be events of a sample space S of an experiment. Then, the conditional probability of an event E given that an event F has occurred is given by probability of event E when F has already occurred equals probability of E intersection F by probability of event F. Example, a dice is rolled once. If the outcome is an odd number, what is the probability that it is a prime number? Solution. Let A be an event of getting a prime number. Let B be an event of getting an odd number. A equals 2, 3, 5. Probability of A is 3 by 6 equals 1 by 2. B equals 1, 3, 5. Probability of B is 3 by 6 equals 1 by 2. A intersection B equals 3 and 5. Probability of A intersection B equals 2 by 6 equals 1 by 3. We need to find the probability of a prime number, provided that it is an odd number. Probability of A, provided event B has occurred, is probability of A intersection B by probability B is probability of A provided event B has occurred is 1 by 3 by 1 by 2. This results in 2 by 3. We will now define property 1. Let E and F be events of a sample space S of an experiment. Then, probability of S provided F has occurred equals probability of F provided F has occurred equals 1. Probability of S provided F has occurred equals probability of S intersection F by probability of F equals probability of F by probability of F equals 1. Probability of F provided F has occurred equals probability of F intersection F by probability of F equals probability of F by probability of F equals 1. Let us now discuss the first property of conditional probability. The probability of a slice with all the types of toppings, provided that the slice is with green capsicum, is probability of S intersection G by probability of slice with green capsicum equals 5 by 8 by 5 by 8 equals 1. Next, we will discuss the second property of conditional probability. The probability of slices with mushroom, provided that the slices are with green capsicum, is 2 by 5. The probability of slices with olives, provided that the slices are with green capsicum, is 3 by 5. The probability of a slice with mushrooms and olives, provided that the slice is with green capsicum, is 1 by 5. The probability of slice with mushroom or olives, provided that the slice is with green capsicum, is 4 by 5. We are now ready to define property 2. Let A and B are two events associated with the sample space S. Also, let F be an event of S such that probability of F is not equal to 0. Then, probability of A union B provided F has occurred equals probability of A provided F has occurred plus probability of B provided F has occurred minus probability of A intersection B provided F has occurred. Proof: probability of A union B provided F has occurred equals probability of A union B intersection F by probability of F. Using that law, we get probability of A intersection F union probability of B intersection F by probability of F. This results in probability of A intersection F plus probability of B intersection F minus probability of A intersection B intersection F by probability of F. Probability of A intersection F by probability of F plus probability of B intersection F by probability of F minus probability of A intersection B intersection F by probability of F. This further results in probability of A provided F has occurred plus probability of B provided F has occurred minus probability of A intersection B provided F has occurred. If event A and event B are disjoint events, then probability of A intersection B equals 0. Probability of A union B equals probability of A plus probability of B. This implies that probability of A intersection B provided F has occurred equals 0. Probability of A union B provided F has occurred equals probability of A provided F has occurred plus probability of B provided F has occurred. Next, we will discuss the third property of conditional probability. The probability of slice with mushroom provided that the slice is with green capsicum is 2 by 5. The probability of slice with no mushrooms provided that the slice is with green capsicum equals 1 minus the probability of slice with mushroom provided that the slice is with green capsicum. This results in 1 minus 2 by 5 equals 3 by 5. Property 3. Probability of E dash provided F has occurred equals 1 minus probability of E provided F has occurred. From property 1, probability of S provided F has occurred equals 1, statement 1. S equals E union E dash. Replace S by E union E dash in statement 1. Probability of E union E dash provided F has occurred equals 1. Probability of E provided F has occurred plus probability of E dash provided F has occurred equals 1. Probability of E dash provided F has occurred equals 1 minus probability of E provided F has occurred. In this module, you have learnt about the properties of conditional probability. Let E and F be events of a sample space S of an experiment. Then, property 1, probability of S provided F has occurred equals probability of F provided F has occurred equals 1. Property 2, probability of A union B provided F has occurred equals probability of A provided F has occurred plus probability of B provided F has occurred minus probability of A intersection B provided F has occurred. Property 3, Probability of E dash provided F has occurred equals 1 minus probability of E provided F has occurred.